Okay. Uh, Good evening, everybody. My name is Mark Steiner. I'm involved in the amateur radio in the International Space Station, also known as ARISS. One of my functions is the vice chair of the ARISS-I International Organization. I am also the NASA liaison between the ARISS technical teams, AMSAT and ARRL, and the international organizations, and working with NASA. So tonight I'm going to talk a little bit about ARISS, some of the stuff we've done, a little bit about contacts, a little bit about ARISSat, and I've set up in the background. You can see K6DUE, which is the Roy Neal Memorial Station. That was his call sign before he passed away. That's one of the telebridge stations we have set up to help out with the ARISS contacts around the world. I'll cover a little bit of that when we get to it. All right, let's press on then. So what is ARISS? It's an international program, and you hear a lot these days about STEM, which is science, technology, engineering, and mathematics. And the idea is that we inspire students and young people around the world to get interested in STEM using the unique capabilities of amateur radio and actually amateur radio on the ISS. We're excited because quite often the local community is drawn into this event. It's a big deal for them quite often, once in a lifetime, for students to be able to ask questions directly of the astronauts and cosmonauts on board the space station. It also provides a platform to do some experimentation with various amateur radio activities. We've done some slow scan. Haven't done any real-time TV yet coming down, but there's a possibility of that happening as well. And also interested in getting the interest up in amateur radio as a hobby for kids and anybody who experiences it. What's key is that it's a worldwide network of amateur radio volunteers who work very hard, many hours, to put this together. There's probably, regularly speaking, 50 or 60 people from all around the world that help do this. And if you guys have any questions, just pop right in, and I'll answer them rather than waiting all till the end. So whatever you want. All right, so this is just kind of a pictorial representation to spark the students' interest. It was originally used for crew family contacts when ISS was first launched. I think the first one was '99, but when it was first permanently had first permanent crew on board. Communications were relatively bare bones compared to now. They have an IP phone with KU band, but before they had KU band, they actually used amateur radio for the crew members to talk to the family as a support of crew psychological ops. And even as they started to get some of the better radio systems on board, we've been told that the best audio on the station was through the ham radio contact. And down to the right, you can see some of the pictures of the equipment that actually flew on Mir, which was, the predecessor to ARISS was SAREX, or Shuttle Amateur Radio Experiment, and then also helped out with some of the operations on Mir. Oh, I went the wrong way. There we go. All right. So FGB is the Russian service module. That's where we've had the Ericsson radio, or voice and packet. It was actually turned on 2 weeks after the first crew arrived, making first payload on the ISS. So I think that's kind of a neat thing. Later on, we developed antenna systems to put 4 of them on there, and actually I have one mock of it in the background here, and I'll show it once we're done with the slides. Put it on the outside of the service module, and we also have antennas now on the European Columbus module. Then later on, we put a Kenwood D700E in the Russian segment near the dinner table so they can look out the window and talk to hams. As the station's gotten more complete and the crews have been busier, there's actually been less time for amateur radio activities. Of course, that always depends on how interested the crew is in amateur radio. Had hundreds of schools. I think we're somewhere around 650 contacts that we've performed since the program started over 10 years ago. Yeah, November 2000. We estimate that we reach over 15,000 students each year with our amateur radio contacts, because a lot of them are piped through whole school districts, and occasionally in some of the other countries it goes over their commercial television and radio across the whole country. And we were actually shown in the ISS IMAX film. So if you get a chance to see that, you get to see a high-def version of the contact. They filmed some of it on the ground and also on space station itself. Here's an example of some outreach we did at the National Air and Space Museum back in 2008. You can see here with these are the Dave Clark headsets on the top left here. You can see the cursor there that they get to try on. That's identical to the ones in flight. You can see the equipment here. This is a bag that the Russians used to get some of the equipment up there. This is a mock-up of the antenna. It's probably looks like the same one that I have here in the background. And let's see, that's one of the Ericsson transceivers there. We have a display set up so we talk about amateur radio, and we put this out where we have a chance to do large audiences. And we have astronaut Lee Morin getting them ready for the contact. It's one case where we were actually able to set up a contact, and the people who walked into the Air and Space Museum that day were treated to a contact with amateur radio, or with the astronauts on the ISS using amateur radio. So we've talked about having flown on Space Shuttle Mir and the ISS, and it's been ever since the beginning. It's been an international effort to pull the program off. So right now, I think we're still at 9 international partners: Belgium, Canada, France, Germany, Italy, Netherlands, Japan, Russia, and the United States. And there's a memorandum of understanding that formed ARISS as a working group to represent all amateur radio operators to the ISS program. It's primarily an all-volunteer team. There are a few people who work at Johnson Space Center in the operations who are paid, so they're lucky enough to be paid to do their job with amateur radio. So there's two options for doing the contacts: direct and telebridge. The direct contact installation is shown here. That's when things work out. A lot of things have to come together for a direct contact to work. The crew has to be awake, so they have, that's one set of sleeping schedule. That has to be whenever the school or institution can support it, and the ISS has to be going overhead at the same time. If that works out, it's a direct contact, and you can see we have circularly polarized Yagi antenna with a preamp. It goes into the prime station through a 2-meter transceiver. We typically have a computer control the rotor, because you have to point in this case to make sure you keep the link well enough, azimuth and elevation here. And then we also ask folks to have a backup with just a 2-meter antenna, vertical antenna, with a separate transceiver in case something happens in the primary station that there's still a way to talk. Contact will not be quite as good, but you can generally still get the questions up there. It's also helpful to have the orbit prediction program and the tracking interface. It's a good way to get kids interested. Why is there only a 10-minute window that we can talk to space station? It gets a chance to talk about orbits, and which then gets them involved in math. And again, everything is aimed towards getting them interested in STEM activities. We also have telebridge. When that doesn't work out, that stations overhead, we have amateur radio stations around the world. They actually show the one here in San Diego, California, but there's also one here in Greenbelt, Maryland, where I'm located. And let's see, W5RRR Johnson Space Center will soon be back on as a telebridge station as well. So you see the school could be in Seattle, Washington, and the uplink station, which means the ISS is going overhead in San Diego. We have a bridge moderator, kind of like an MC, to pull things together that could be in Greenbelt. And this map changes just about for everyone. The school could be anywhere in the world. We have moderators from around the world, but it's all tied together through Verizon in Chicago. They use phone lines to tie all the audio together. So you guys have expressed some interest in trying to pull off a contact at next year's Makers Fair. I think it is. We'll talk about that in a little bit. The key to success is careful planning and preparation. Should always make sure everything's worked out so you're not trying to pull anything together on the last day. You know how Murphy can always rear his ugly head when that happens. Minimize the technical overhead on the school and keep the setup as simple as possible. Always make sure you have a backup plan and practice. Make sure that the students are ready to ask questions. Don't get nervous when the mic's put in front of them. So I'm ready to move on to talk about SUITSAT-1, which flew back in 2006. You see on the left a picture of it just after deployment as it was floating away. What happened there was Sergei Samburov, the Russian representative to the ARISS International team, came to him and said, hey, we have to get rid of spacesuits. Russia has a different policy than the U.S. They certify items in space for a certain length of time, and then they say, okay, they're done, we'll get rid of them. So their suit had reached the end of its useful life, and he wanted to put an amateur radio station inside as an education outreach event. So you can see here on the right, the antenna was mounted to the helmet, and then we packed the electronics inside the suit, along with a battery that was charged but was at the end of its life. And I guess there was also some dirty clothes that they put in there to get rid of the trash. That's one of the problems they have in space stations, getting rid of the trash. So we had a 2-week battery-operated satellite station. You detect a theme here because we'll talk about the SUITSAT that's up there now. International student messages. There was a slow scan TV picture that was transmitted, some telemetry. And we had invited students to submit drawings, and we put that artwork on a DVD, and that flew on the outside of the spacesuit. It was deployed in February and re-entered in September of 2006. Then we moved on to ARISSAT-1, which was originally SUITSAT-2. Sergei said, hey, there's going to be another suit available. Let's do it again. So we upgraded some capabilities of it, but unfortunately, the development ran a little bit longer than the suit was available. They had to get rid of it, so they chucked the suit without the amateur radio. We repackaged it onto a frame and actually upgraded its capabilities. That's what was launched on August 3rd. So this is a top view of it. There's a control panel that we use to provide a safe deployment. You want to make sure that it doesn't power it up before it's safely far enough away from the crew in case anything unexpected should happen. The battery was, safe on board, but you have to be extra careful when you're talking about human lives. So NASA is very careful about the safety policy. So we had inhibits to make sure it wouldn't turn on or transmit. It would hate to have RF get into the suit and mess up the suit electronics. So we have this control panel. There were 4 cameras on board in 2 locations, each one with a mirror, so we could get 2 different axes. Down here, sorry about that. Down here, there's 2, and then there's 2 up top. We had the Kursk student experiment that was measuring vacuum. That was provided by the Kursk University in Russia. We had 6 solar panels that were provided by the Small Explorer or SMEX program here at Goddard. The Russians provided the battery. That was actually a silver zinc battery that they provided. It was I believe a spacesuit battery that they put together. We knew it was it was certified to be safe, so they used that for us. And then we flew it up separately and installed it in the satellite and put it overboard. Have an antenna on top, 2-meter measuring tape antenna, and then there's a 70-centimeter receiver antenna on the bottom. The RF boxes, and an internal housekeeping unit, a multi-point power tracker to take the power off the solar rays and charge the battery. So I'm not sure how well it shows up there, but this is a deployment sequence from station. This is looks like progress here, and you can see the crew just outside the hatch, and here's the satellite, and as it's tossed, you can see it tumbling as it goes away in the proper direction. And then up on the top right is one of the slow scan television pictures that was captured. It was safe to turn on the satellite. We just made sure we didn't charge the antennas, but we did take pictures of the camera, hoping to get a good shot of the cosmonauts, and actually we did, and this was received on board. You can see some of the lines in here, some of the static lines. The satellite was tumbling fairly quickly. There was a lot of fade in the signal towards the beginning of the mission, so that showed up as noise in the slow scan TV picture. All right, so, and depending on how much time you guys want to spend after this, we can talk more about ARISSAT. I'm going to jump in a little bit talking about why education is important. I work for NASA, and NASA supports this not so much because they're interested in amateur radio and space, because that doesn't really help NASA do its job, but they're interested in the education impact of it. So AMSAT and I pulled some of these charts from what I'm going to present at the AMSAT symposium. So AMSAT had its beginnings in the early days of the space age. Obviously, amateur radio's been around a lot longer than that. So, satellites were still a new thing. A lot of people talk about how Sputnik going overhead influenced their decision to get interested in technological careers. Of course, that was back in 1957. Where are we today? Kids growing up are used to technology. The shuttle is come and gone for them. All the fancy electronics. So technology doesn't necessarily excite them like Sputnik did back then. We find out that education is still important. And if you look at the NASA website, it talks about NASA continuing the agency's tradition of investing in education programs, supporting the educators who play a key role in preparing, inspiring, exciting, encouraging, and nurturing the young minds of today who will be the workforce of tomorrow. So that's from the national viewpoint. We need people who want to grow up to be scientists, technicians, engineers, and mathematicians. But I think that's also important for amateur radio, to have people who are interested in it and want to get involved in it as a hobby. So the United States, ARISS is sponsored by NASA, provide resources, people, some money, and volume and time on the ISS, which of course is a valuable resource. AMSAT is actually AMSAT from around the world, but USA sponsors AMSAT North America as a sponsor of it, as is the American Radio Relay League. And the League and AMSAT provide resources as well, volunteers, a few paid employees, not to a great extent because both those are nonprofit organizations. There's not a ton of money for that. And they have provided flight hardware and test hardware and the use of amateur ground stations. Biggest thing right there, though, is volunteers. So we're focusing more on education as part of amateur radio involved on the space station because Congress is telling NASA you need to make sure you get out and measure the outcomes of the education to make sure you're spending the money wisely. So we can't just say, hey, we're doing it for education. We actually have to measure it. And that's the Teaching from Space office, Flight Projects office at Johnson Space Center is the sponsoring organization for ARISS. So they're emphasizing more and more that we need to provide educational content. And to that end, in this past spring, we had a new beginning for ARISS contacts. It used to be that a school or an institution would find out about ARISS, whether it's a teacher who found a ham or they just happened to come across it, and they would send an application and say, hey, I want to do this. And if the application was good enough, or eventually we would work with them, and it got good enough to the point where we said, yeah, let's go with it. They get a contact. But this past spring, we went to a new method to emphasize education even more. So Teaching from Space issued a call for proposals. They have a mailing list of over 18,000 teachers, educators, institutions. And I guess it was actually passed on to Twitter, so we figure somewhere over 1 million people saw this advertisement for amateur radio, chance to propose for an ARISS contact. And the idea is that they would concentrate on the educational program that surrounds the contact and not as an application embed showing that they were able to do a contact. So that allowed AMSAT and the League to step out to the schools that had really good education proposals and help them be able to focus on the technical implementation of the contact, which is the strength of AMSAT and the League. So NASA says, you're an educational school or an institution, tell us what you're going to do to make it a good educational program, and then the League and AMSAT can step up to help make the contact happen. So we chose 5 primary schools and 10 alternate schools and institutions, and we will start giving them contacts in mid-January for the next 6 months. And then this November, there's going to be another call for the following 6 months, and that should happen every 6 months after that. And that is, at this point, the only way to get a contact is to do the application. And I can get into some more of the details of that if you have questions once I'm done. There's just a few more slides here. Actually, this information where you can go, you'll have these charts. You can look at that later. But so, how can you help? We have volunteers who are called mentors. They help the schools that have been selected go through the process. They're not necessarily on site, although sometimes they are. It's just a point of contact within the ARISS organization to help the schools get ready for the event. Picture on the left here is a school that we did locally here in Bowie, Maryland, where we got up on the roof and set up a portable antenna. You can see the 2-meter beam here on a short tower, anchored down with concrete in the bottom. They just put a new roof, so we had to be careful on the roof. We ran wires over the edge and set up a station at the school for direct pass. And on the right, you can see this is Gaston Bertels from Belgium running a contact, and I'm not sure exactly where in Europe that picture was taken. There's also looking for folks to be local volunteers. If there's a school near you that has been selected and someone has an interest and has some amateur satellite experience, then you can help the school if they're trying to pull off a direct contact. Also, we need folks to go in. With the telebridges, you don't have to have the ham radio station there, since we take care of that in the telebridge end, but they need help with the audio equipment. Those various ways to help make that happen. So, 20 years from now, in 2031, we're going to have enough men and women, STEM careers, to help the U.S. maintain its competitive edge. In 20 years, will amateur radio have enough people interested in technology so they'll get involved and keep the hobby alive? And then in 20 years, is there going to be some bright young engineer who's doing great, and you can say, I helped them get their start because I made an ARISS contact happen. So that's the basic reason I'm involved in this. It's fun, but it's really about getting young people interested in amateur radio and STEM careers. And here's a couple of websites. I also have my email on there, so if you have a contact.
Thank you very much. That was fantastic.
All right. So I don't know how much time you have or want to spend, or if you're ready to say, all right, we've seen enough of them, go ahead and hang up, or if you want to talk some more, I can show you around the station, carry the computer around, whatever you guys want to do. It's up to you.
Why don't you give us a little bit of a tour there, Mark?
Sure.
If you could.
So that's just a little work desk we have. I'm going to pan around here. So this is our operating console. We have a Kenwood DS2000. Pull in. This is kind of hard to do. I apologize. I probably should have practiced this some more. That's our main radio we use to talk. And you can see the rotors over here, controlled by the computer.
Nice.
And actually, in front, let's see, I can get some better pictures, but this is a mock-up of the antenna.
Nice.
Let me set this down and see if I can get it a little more stable here and get a picture so I can use my hands.
Mark, could I interrupt you with a quick question about the antenna while we're looking at it?
Sure, go ahead.
I've always wondered, I've made many APRS, ARISS, ISS contact using 5 watts and a rubber duck, and I've always been impressed at the ARISS requirements of 170 watts plus with the beam. Is that a matter of intentional QRM or some kind of QSB that's unique to that antenna they use for the ARISS contacts?
It's mostly meant to make sure that we capture and it stays locked on our signal in case someone else does accidentally get on frequency. We do keep the uplink frequency confidential, but you just never know when it might happen. So it's primarily to make sure that it's rock solid copy. And there is some fading in it occasionally as we get some configurations of station, especially around the antenna pattern. So it's kind of both. But can you see the antenna okay? The window's really small here. It's hard for me to see.
Yeah, no, we can see it pretty good actually.
All right. Let me see if I can rest it and get 2 hands here. That pretty good?
Yeah.
All right, so we have a plate that it's mounted on. And this is the 2-meter antenna. It's actually 2 meter and 70 centimeters. And this is a tuning stub. It's not really a ground plane per se. It's more of a tuning stub. We have our L and S band antenna here and a diplexer underneath to split the signal coming in. And then this is the handle that they use to get it there and a mounting block so it could... we had a clamp underneath here, the EVA clamp that the Russians used to clamp it to the handrail, and that's how it's mounted permanently.
This is for all amateur radio on the space station, or just for ARISS contacts?
They're really pretty much one and the same. There's 4 of these on the outside of the service module. One has been disconnected because the Russians needed a cable for something else. and there's one that is set for 10 meters that we've never really been able to pull off because of the consideration for what the SWR is, and getting a station up there that can handle the power needed to do that. So there's actually, the first station was used, first amateur radio contact used what they call the Sirius antenna. That's the Russian name for the telemetry antenna on the service module when it was launched. And then they disconnected the radio from it, and we were able to tune up on it, and that's what we used for the first few years, so we got these antennas installed on the outside of the service module. Okay?
All right.
Fantastic. We have one more question?
Sure. Oh, yeah.
The uplink frequency is confidential for the ARISS contacts, or how does an individual then get that uplink to make a one-on-one contact outside the school group?
I'm sorry, I couldn't quite pull that out. If you guys could repeat that.
Sure.
The question was, is there any? I guess what I'm gathering from the question is there any way to have a non-planned contact with the astronauts, being that the uplink frequency to talk to the astronauts is confidential?
Well, the uplink frequency for the school contact is confidential, but there are published frequencies that are open for the public whenever you might find an astronaut who has the time and the interest to do a contact. They've been very busy lately. There haven't been that many that have had that much time to do free contacts, but Doug Wheelock over the summer actually did a lot.
What's a typical yearly haul of astronaut contacts from the space station, would you say? Unplanned contacts.
Unplanned? It really depends. You get someone like Doug who got excited. I think he did. I'm not sure we've tracked that actually to know the full number that he has done. There's someone like Bill MacArthur, or his name's dropping out. Mike. I'm sorry, his last name dropped out in my mind. But when Mike Foll was up there, he did a lot as well.
Cool.
Nice.
So it's unfortunately it's a little tough right now with everything going on. Mike Fink was the name I was thinking of. He's actually going back up, so we hope that he'll be excited about it as well.
I know the last space tourist I remember, Garriott.
Yes.
I know he was doing some slow scan. Is the slow scan device still aboard the ISS?
It's still there. It eats batteries like you wouldn't believe. About every hour or every 8 hours, it eats up a full set of. I think there's 4 batteries in it, 4 AA's. And as you can imagine, the mass going up is very expensive, so they don't have a whole lot of batteries to dedicate to that, so it's not too well used. We're trying to see if we can get a battery eliminator up there to provide power to it, but it takes a lot of work to get that system set up and configured, especially power. They're worried about a power supply messing up critical systems on board, so you have to go through a lot of testing. It's not an easy thing to do. Plus, you have to get permission to get the weight manifested to go up, and right now there's just not a whole lot of up mass, especially with the shuttle. The last few shuttle flights were really crammed full of getting essentials up to space station.
Gotcha.
Do we have any other questions from the group here? Yeah, go ahead, Dave.
I just have a question about the repeater mode, which seems to have been not active for a long time, but used to be active. Can you talk about that and what the status is of that?
Can you talk about the repeater mode, Mark? It seems that it hasn't been active lately.
That's right. Yeah, it's an interesting mode on the Kenwood, but I don't know if anyone's run a Kenwood D700 here on the ground, but to run in the repeater mode, it gets very, very hot. And in space, there's no convection. You have to worry about forced air to get things cool, and there's just not a strong enough fan, so it gets very, very hot when they put it in repeater mode. The other part of the problem is it takes 26 different steps to get it from the school configuration into the repeater mode, and I think about that many to get back, and there just haven't been that many crew members interested in setting that up. Unfortunately, we've not been able to get a computer that could send the commands to set up permanently. So it's mostly a matter of getting the time and the crew member who's willing to spend that much time, and it is very hard on the equipment.
You know, Mark, I've got a question for you. I have a friend of mine who happened to make a random contact with an astronaut, and I don't know which astronaut. I don't know exactly when. I believe it was this year. But, you know, I've always wondered, when is the best time for someone who's looking for a random contact with an astronaut to tune in? When are they most likely to hear someone?
When they're awake.
Sorry.
That's obvious, yes. But typically, they would do that in their free time, so you kind of have to follow what's going on. They get some of the weekend times free, and also before they go to bed. They follow generally UTC. I'm not sure when the bedtime is for them, but it's probably like 9 or 10 UTC that they start settling down, and you might have some luck capturing that. Or sometimes they get on, if they're really excited, they may do it over mealtime in that few minutes. So it really is just kind of random whether you catch them or not.
Any other questions here?
Is there a program to train and license astronauts as ham radio operators?
So the question was, is there a program to train and license astronauts as hams?
Yes, actually, Kenneth Ransom, N5VHO, is very active in that. He's one of the full-time employees down there. And when the astronauts come in as a incoming class of astronauts, they have, of course, lots of generic training. But the education office jumps in at the beginning and says one of your duties of astronauts, or as an astronaut, is to support education and outreach. And part of that is amateur radio. So we let them know what amateur radio is. We get on their training calendar and get them their licenses so they can operate on board. There've been very few, actually, astronauts who said, no, I don't want to do that. And actually some have gotten the bug when they've been on orbit. They generally... The majority of the astronauts are willing to get their license and make it fairly easy. I mean, they have to follow all the requirements as everyone else. They just try and get on their schedule and schedule the VEC exam for them based on their training schedule. Most of them will do that, get their license, and they're quite willing to do the school contacts, but that's about it as far as their interest level.
Do we know when the next Space Tourist is going up? Are there plans for that? And do the Space Tourists ever conduct school contacts?
Yes, they do. They did do school contacts. Now, unfortunately, at least for a while, with the shuttle down, there are no more tourist seats on the Soyuz. For a while, we got a chance to do that when the shuttle was providing all the capability to get crew members up there, and the Russians could launch a Soyuz with a paying customer, a space tourist. But right now, they're all booked solid getting crew members up and down. So I don't know if we'll ever have space tourists there again, at least until the commercial market takes off. Then there's a possibility of that.
Cool.
Interesting. What's the lifespan of the space station? How much longer does it have up there?
I think they just recently recertified it to go out to 2025, which would be about 15 years. And at some point, I imagine that they'll look at it again as they get closer to that and say, well, what really could fail, and what can we do to maybe keep it up there longer? It's hard to think about it being a significant way through its. Oh wait, that's 25 years. I can't do my math. I'm sorry. When it was launched just before 2000, that's 25 years.
Do we have any other questions? Going once, going twice? Mark,
all right.
Thank you so much for the presentation. I really appreciate it. I think we all very much enjoyed it.
Yeah, I'll spin you around so you can take a look at everybody and give you a wave.
All right.
Lights on.
I'm glad I had the opportunity. This worked out really well. So, thanks, everybody. And if you have any other questions that come up, feel free to shoot me an email, and I'll do what I can to answer the questions. And take a look at the website. But it's a pretty cool part of the hobby. I'm glad I got a chance to do it. I do have one picture to share. That's not it. Hang on just 1 second.
Sure.
We got to go over to Russia, and while we were there, we got to go to the Energia Museum, and while doing that, I got to stand next to Gagarin's capsule.
No way.
Nice.
Yeah.
It's not for the claustrophobic, Mark.
Whoa. Yeah. I'll tell you, I wouldn't want to be inside it. They're pretty crammed. There's not much free space in there. But actually, the first time, this is the second time I got to see it. The first time, it was just right out there. If I wanted to, I could have walked up and scraped a bit of it off under my fingernail. I obviously didn't do that, but it's pretty cool to be that close to Gagarin's capsule. That meant a lot to me. It was pretty cool.
Mark, thank you very much.
Thank you very much, Mark. We really appreciate it.
All right, well, thanks for making time to listen to me. I appreciate it. You guys have a good rest of the meeting and safe travel home.
Cheers, Mark.
Take care, Mark. Thanks.
Bye-bye.
73 is Mark.
73.
73.